Hello, everyone. Wow, it's an awesome crowd here, much bigger than last year. Okay, so you've heard us maybe give these keynotes before, and usually the topic is making big data simple and democratizing it. Today, I want to focus on one of those particular use cases that we've been working on a lot. It's not the only one, but it's the one that has to do with AI and machine learning. And later on in the talk, I have a really exciting announcement I want to make to you guys. But before we get there, I want to just go through a little bit of background. So it's no news to most of us here. AI is changing the world. I'm convinced, at least personally, that soon, in not so distant future, we'll have millions of these on the streets, everywhere, self-driving cars. We already take it for granted, but voice recognition is already happening. People have these Alexa devices in their homes that's listening all the time when they speak to it. And I'm sure you know of AlphaGo, which it was Google's deep learning framework around Go that beat the Go champion of the world. So the question is, this has been going on for a while. People have been doing machine learning and AI for 30, 40 years. So my question is, why is it happening now? Why is it exploding just now? And the answer to this, as you might guess, is data. So what really made the difference is the amount of data that we have now and the compute power that goes with it. And it's also easily accessible now, both the data and the compute power in the cloud. So we now have things like clickstreams, we have sensor data, we have video, we have speech, handwriting, and all of this data is enabling us to better train, better tune, better validate our machine learning algorithms. So this is really what's made a difference. And the more data we have, the more complex models we can build. So this is great, but one of the things that we don't often talk about is that the companies that are really doing well with AI are these really big companies that have thousands of engineers. So most of the companies out there are struggling with it, and we see them every day. It's not so easy to get this stuff working. So why is that? Why is it so hard, and why do you need to have thousands of engineers to make this stuff work? So my favorite paper came from that same company that created AlphaGo, Google, and the title actually says it all. It's a really interesting title. It says, Hidden Technical Debt in Machine Learning Systems. And it was published by Google in a machine learning conference last year called NIPS. So what they're talking about here is that just like other software systems have technical debt, machine learning systems have also technical debt. But the technical debt in these systems is different. And what you see here in this image and this figure from the paper, and you can read the figure, each box here in this picture represents the amount of work that you need to do to get a machine learning pipeline working end to end. And in the middle there, there's a little black box, and it's very hard to read what it says, but inside of it, it says machine learning code. So what they're saying is that most of the time and effort in building machine learning systems goes to configuring them, collecting these massive amounts of data that these algorithms need, doing feature engineering, extracting the features that you need, tuning that, and then running it through machine learning, then doing the verification, using tools to make sure that you're managing all these resources that you have. So really, the hard part of this is all the other stuff that goes around it, not necessarily running the algorithm. You can ask anyone who does machine learning and they will tell you this. So how do we democratize this? And I don't want to lead the witness, but you probably know what it is. Okay? So we believe Spark is the perfect solution to this. And the reason for that is Spark was exactly made for this. Spark is a plumbing framework that is used exactly for these things. Spark can be used to connect to many of these frameworks that are out there. It supports already languages like R, Scala, Java, and works with all these storage systems. And in particular, we know that it's really flexible. So the flexibility comes from all these integrations and all these great APIs that people love. It's also fast, but it's fast in two ways. It's fast in that we already know that it can beat things like MapReduce by 100x, but it's also fast because it's simple to use, so it's faster for you to prototype and develop ideas using those simple APIs. And then finally, it just automatically scales out and works on big data sets. Okay? And we can see here that actually Spark already today supports solving many of these things that you see on this figure. So it can be used for data collection. We know that. There's been a lot of talks on this. Feature engineering, using the data frame API to tweak the models that you want to build or the featureization process, data verification, and then calling into machine learning algorithms that exist. So it's already a really great fit for this. However, there are still some gaps. So if you want to do this big data processing and doing machine learning with Spark, it's still not that easy. And the gaps that remain are the following. First and foremost, you still have to set up all the infrastructure that you need. So you need to get clusters up, configure them, make sure that they're running, and securing them so that they can access all these data sets that you want to work with. So that's one. Once you've done that, you now have the infrastructure ready, but it can still be hard to use Spark and to collaborate and interactively work with these data sets to do your feature engineering. So we need a way in which we can empower teams to be more productive so that we can have many data scientists and analysts collaborate with each other on these data sets. Once you've done this, now you have your infrastructure, and now you have your teams that are empowered so they can use Spark, but then the hardest part remains, and the hardest challenging part is how do we actually move this into production? So that means no more human in the loop, and what we want to do now is we want to have robust machine learning pipelines that are just running on their own. They're training, they're doing recommendations, and they're highly available, and they're fault tolerant. Okay? So at Databricks, we believe that we have a solution that's closing this gap. And we announced earlier this year Community Edition, where we're democratizing access to this framework. What it gives you is it's a cloud-hosted data platform. And what that does is that it provides a virtual processing layer. So it gives you instant access to Spark clusters with a few clicks or using REST APIs. And this separates compute from storage. So you use these Spark clusters and you connect them wherever you have your data residing. We'll provide integrations for you so that you can really fast access the data wherever it resides. And we cache it on the first access so that it's fast. What this lets you do is to be much more agile. So you can now scale up and down your Spark computations as you need in a matter of minutes. Second, I said we still have a skills gap. We need to empower the teams. And there we have an integrated workspace, and you've seen it. There was a demo by Greg yesterday. You can see how easy it is to use that. There, you have a Google Docs-like environment where you can collaborate, you can create notebooks, dashboards, reports, and you can do real-time exploration of these machine learning data sets that you have. So this accelerates the time it takes to get to value. So you can quickly prototype, collaborate, and get your things up and running. And then finally, we have an automated Spark management environment that lets you do workflows for ML that are just running in a highly available, fault-tolerant manner, and they're really performant. Okay. So I'm going to talk a little bit about some use cases that we've seen, people using exactly this framework. And you might have seen one of them. We had Capital One at Spark Summit West just recently announced that they're doing machine learning on the Databricks platform through Spark. And it's really exciting. So every credit card that you swipe goes through this machine learning framework, and they're detecting if it's fraudulent or not. Another use case is DNVGL, a European company that's predicting energy demand using massive data sets of weather. So these are petabyte scale data sets. Elsevier, European publisher, the largest publisher, has massive amounts of text documents. And what they're doing is they're doing natural language processing, so NLP, to extract author graphs and do recommendations with that. Riot Games, this is a pretty cool use case. They can predict in the first 30 seconds that you're playing a game whether you're going to churn and whether you're not going to like the game. And then good things can happen to you. And then finally, Siemens can detect in advance with pretty high probability that some machines or some of their equipment or wind turbines are going to fail. And what it can do is they can send out people there that can replace those parts, and then they can avoid having to pay for that. Okay? So I want to talk about the use case, however, that's really exciting, and this is something that we've seen more and more this year. And this is of deep learning. We already know here that deep learning is really, really good at image recognition and NLP, but we're also seeing now use cases like detecting cancer, understanding Mandarin, or inferring location using landmarks. And to the announcement that I promised you, I'm really excited to announce today that Databricks is providing you now an end-to-end framework for doing deep learning. So today, we're now releasing in a SaaS fashion something called Tensor Frames, which is a combination of data frames and TensorFlow, and we're giving you access to GPU-based clusters where you can do machine learning end-to-end using the TensorFlow deep learning network. Okay, so what I'm going to attempt to do now is I'm going to give you a quick, short demo of how this would work in Databricks. All right, so this is Databricks as we know it. And what I'm going to do is I'm going to go to clusters. I already have some prepared clusters running, but I'm going to create one. And I can say I'll use GPU cluster. And what you can do now in Databricks is that now you can select this special version of Spark that is compiled with all the drivers that you need and everything that's needed to do GPU processing. So we see here, GPU here. So I select that, and I can then pick that I want an on-demand machine. I can select the number of machines I want. I'm going to pick a smaller cluster here. And I'm going to pick a particular machine type. So I'm going to pick the GPU-based instances. So I'm going to pick these G2 8x large machines that have GPUs in them. I'm going to say create cluster. All right? So this is now kicked off, and it's creating a cluster. These machines take a little bit longer to launch. So I've launched one already in advance called Databricks GPU, and we're going to use that to work with TensorFlow. All right. So what I'm going to do next is I'm going to take an image, and I'm going to run it through a framework that I've prepared. So for that, let's Google up a picture. All right. So this is Greg Johnson, and let me see here. I want to pick this picture here. I'm going to copy the image address, okay? And let's do some deep learning on this. All right. Okay. Okay, so let's go in here. What I'm going to run here, so I'm going to paste this image in here. So we can start using this. And I'm going to attach to our GPU-based cluster. And what we see here is, this is Tensor Frames. Actually, let me put the little title here so you can see. Okay. And let me make it a little bit bigger. All right. Okay. So what we see here is some Python code. What this does is, in particular, it loads in TensorFlow as TF variable in Python, and it loads in also Tensor Frames as TFS. Okay, so I can just execute this, and you can see that it's running on this GPU cluster. Then I'm going to import some visualization libraries that can process this image that we have, that we pasted in up here so that it can load it in. And then I'm actually loading in this model, and this is a model that Google published. It's called Deep Dreams, and what this model does, it's a deep learning model, and you might have heard of it. What it does is, it's trained already, so this model can recognize the particular one I'm using. It can recognize features of images of animals, dogs, and it's really good at recognizing dogs, okay? But what this does is, I give it an image, so in this case, we're going to give it Boris Johnson, and it's going to see if it can find dogs in the picture, right? And it might sense that there are some dogs that fit in some places, but then after it's done that, we're going to actually reverse this, and we're going to emphasize those. So we're going to, instead of converging, diverge it so that we can detect more and more dogs in the picture, okay? So in some sense, what you're doing is you're hallucinating. You're increasing the probability that you see things in pictures that maybe aren't really there, all right? So that's this framework here. And what I'm going to do is I'm just going to say run all here and run through this code. So that's what this does. And then we have this big function that actually does most of the processing. It creates all of the layers, and it actually calls in to our process. So this is the picture. So it loaded it in. That's the picture it's going to work on. And now Tensor Frames is running here. So I'm running this big function, and I'm saying I want n to be equal to 4, and I want to do 6 iterations. So it's going to be 24 Spark jobs here, and we can see it's now on the 9th job that it's running through, okay? So what it's doing is it's taking Tensor Frames, running them in parallel on these machines, and parallelizing it through Spark jobs, calling into TensorFlow. So we can see here, if we want to debug, and if something goes wrong, we could go in and see the Spark job that's running exactly here. Right? So you can see here, it's going through this process. Okay? All right. So while it's doing this, let me switch back and tell you why I think this is really cool. What this enables us now to do is to have an end-to-end framework where we can do deep learning. So we can use this framework to launch our clusters, to do all the infrastructure management with a few clicks that you saw. Then you use the just-in-time data platform to ingest your data and access the data that we have. In this case, it was a simple image, but it could have been a much bigger data set that you're training on. You can do the feature extraction using the data frame API that Spark provides. And then finally, with this Tensor Frames that I showed you, you can call in and use GPUs on these clusters to use TensorFlow. And then finally, I haven't shown you, but you can also easily migrate this to a production environment where you can productionize this. All right. So let me go back here and see if it's done with these iterations. And we see here. All right. So it found some animals here in this picture. All right. There's an eye here, and there's a little dog here. And I have another iteration that I had more iterations that I prepared in advance here that we can see here. This is a more accentuated one that I ran for more runs. So as you can see here, TensorFlow is hallucinating quite a bit. All right. So that's it. So in summary, Databricks' mission has always been to simplify big data. And with these new developments that I showed, we're now taking a next step in that journey, democratizing deep learning by making it really simple for everyone. Thank you.